I'm John Runkle, and I'm going to introduce Steve Shanks to you as well. So unfortunately, you're stuck with us for an hour here. We are going to talk about commissioning, but we're going to talk about all the things that are just not commonplace to commissioning, like MEP. We're not talking about any of that. You don't want us talking about that because we don't know much about it. Steve knows a little bit about it. I don't know anything about it. But it's great to see everybody. It's great to be able to do these things in person again, right? And enjoy each other's company and everything like that. This has always been a great show, great event for us, and appreciate the opportunity to be here today. So we're here in a couple capacities, here for Intertek, but also I'm the current president of the Building Commissioning Association, BCA, which is kind of like a sister organization to ACG and everything. And I think part of that is it's great to see so many people enthusiastic about commissioning, right? And it's great to see the passion, the interest, and that all of us are pulling in the same direction. Obviously, I think one of my goals this year as president is to make sure that we're reaching out to other associations and working together as closely as we can. And so that's something that's a challenge for everybody in this room. If we can, let's try to work together, because I think there's a lot of things that we can accomplish together. It's great to be here today in that capacity. And I also wanted to say there's another thing that we've been working on with Iecc, and I don't see Alec. Alec's not here? Oh, Alec is back there. Okay, Alec. See, the guy raising his both hands over there. Not under arrest, but so Alec and Iecc, we've been working together to develop a certification for building enclosure commissioning professionals, right? So if you are interested, and we're almost ready, so we were reviewing exam questions, I think hopefully for the last time, last week. So we're within a couple months of having that done, and that's been a long time in the making for those of you that have been following that. That started about 10 years ago at ASTM, and is finally coming to its conclusion, which we're all excited about. So any questions with that? Alec's got a booth. Go see Alec, and we're excited for that. So with that, I'm going to let Steve go ahead and run with the first half of this, and you'll be stuck with me for the second half.
Thanks, John. So tomorrow's commissioning beyond MEP. So whenever John and I were talking about this presentation, obviously what we've gone through with COVID has been significant in some of our practices. I've got allergies, did my test, it's not COVID, it's just allergies. And too much flying around now that we can start flying again, right? So we also have significant changes that are coming in design standards. We know we have clients who have significant concerns about the indoor health at their buildings, and we also have a lot more modular construction and off-site construction that's happening, and we know that's just going to accelerate because of the value that brings to a project. So the learning objectives are directly related to that. I'm going to talk about state of the practice for BECx, along with functional performance testing. Also going to talk about energy codes. I've been working on codes for over 20 years, not because I like it, but because it's how we move our industry forward. It's how we develop a legacy and opportunities for our professions to have more involvement in transforming the built environment. Then John's going to talk about Iecc and offsite construction and a lot of what's changing in construction practices generally. So whole building commissioning, total building commissioning, would typically be thinking in terms of MEP, HVACR as kind of the primary work of commissioning on a project. And we recognize that it's still BECx, life safety ICT is secondary on some, not all projects. And then we have the subsystems, security, lighting, transportation systems. And really for owners, in my experience, and there's a lot of other performance items that go with this to OPR, but energy efficiency, the cost of owning a building, operating expenses writ large, all those things that are going to impact. It's primarily been institutional type owners, right, that had been doing it. But now we're seeing in IBC and ICC requirements for commissioning as well, even though there is one state that's trying to back that out, and we'll talk about that. And that goes towards the advocacy side that I think we all have responsibilities for. So we all know what the process is, and it's ASHRAE 202 that guides all of that. So, and you know, we have guidelines and we have practices. So we have Guideline 0, we have Guideline 3, which was developed at National Institute of Building Sciences under the leadership of Fiona Aldis and others. And then through a memorandum of understanding, we moved those over to ASTM. So we have the guidelines, which I think most of us know the difference between a guideline and a practice, but for anybody who's taking the test, might be an important thing to remember. Guideline just informs knowledge and informs approaches to projects, whereas the practices themselves are instructions for how to actually perform it. It's not a protocol, it's still a method, but it's how we conduct that practice on a project. So what is BECx? It's just like commissioning. It's OPR driven, and then we have to make sure that we've got good communication on the project, right? Our role in a project is primarily appellatory. So if we're not able to be persuasive, compelling, collaborative, then we're not going to be able to be successful. And that starts, of course, at an OPR charrette. If you can get one, I'm always an advocate for an enclosure charrette as well, particularly on the kind of buildings that we see around DC and some of the more complicated commercial projects that we're involved with. And I wanted to also differentiate just quickly the difference between enclosure commissioning and enclosure consulting. It's not uncommon for an architect to have somebody involved in design assist and perhaps through their project doing consulting. However, that can take on a lot of different forms. It's not well defined, and it's primarily based on reducing liability. Part of what happens whenever it's just straight up consulting is there's a lot less accountability. And perhaps more importantly, it's standards driven. It's not based on the real world conditions related to your project. So this would be a conversation that I would typically have with somebody who's considering enclosure commissioning for the first time on a project and trying to figure out what the real value is for them. And I think just like total building commissioning, it's the process that provides the value to the owner. So we know what pre-design looks like. A BECx plan does look a little different. There's going to be requirements in there for mock-ups and other aspects specific to the types of functional performance testing and inspection that's done on a project. One of the things that's different in BECx is the PFCs really don't do much good. Contractors will, I mean, we know what happens to PFCs too often on our projects anyway. But in commissioning, the real value is having somebody there on site every week, every 2 weeks, actually looking at what's going in, because it's all hidden condition. It's different in an HVACR system where you can go back and put your hands on it. In enclosure commissioning, it's going to be covered up. So if you don't have somebody there looking at it, inspecting it, and doing the in-process testing as it's being installed, then you're not going to get the value for the process. So typically, as you know, people think of enclosures as just what is particular to the conditioned space. However, whenever we're looking at a structure, a building, and we're considering the enclosure, we have to think not only about the parts that touch the exterior environment, but if there's a semi-heated space, if it's an electrical room or mechanical room or a fire pump room, are we going to include that in the envelope? Is it going to be outside of it? How are you going to treat that on a project? Because that's going to define how that part of the work is going. If you have unconditioned space, that's very different. Think of a podium for a mixed-use structure where we see a lot of failures at the point of whole building because that bottom side of that six-sided enclosure has not been well detailed or well thought out. So, of course, going through design reviews, construction documents, meetings, reviewing OPR, mock-up. I mentioned field observations, and I really want to lean into that a bit. So there are enclosure commissioning providers who are doing PFCs and insisting that contractors put together these 4-inch binders full of sheets that, not surprisingly, most of the ink is in the same color and the handwriting looks the same. So that's not helpful because it's different than, I mean, you can ask for a certificate of readiness and you can go out and you can look at it and you can know whether or not it's actually happened. Again, the point being that with an enclosure, it's going to be covered up. So if you're not doing the site inspections, and you get much value than having a contractor trying to do 30 or 40 PFCs for fenestrations on an elevation, as opposed to having somebody out there once every week or two actually on site with the trades and make sure that it's going in the way that it's supposed to. So one of the things that we see is design standards have gotten significantly more complicated over the last few years, and I think this is a fair example of what we would typically see, and this is at a thermal break condition. So for enclosure commissioning, if it's just a brown box, then somebody who's not particularly skilled as an architect or an engineer can do a fair job on doing the pencil trace for the air and water continuity to make sure that it's what it needs to be. However, if it's a more complicated structure, whether it's for a state building or for a commercial building, then you're going to have these kind of situations where you have this thermal break condition where you've got a detail either at a structural condition, and you have to think about your NFPA 285 requirements, meeting your fire, or like on the bottom example, where you actually have a deflection joint at this canopy, and you're having to install a stainless steel flange so that you have something structural to apply your silicone flashing to. So this would be an example where this could look this is going to be very simply represented in your A drawings for a project. But once you get down to the critical interface detail meetings, which on a project like this should be having them weekly, and you should be knocking out the top 5, 6, 10 details that the contractor is going to be facing next, and making sure that they know exactly what they need to do whenever they get there, and that we and the other partners in the enclosure are working to make sure that they're able to be successful there. So expertise and experience is important. We all know that certification is not qualification, it's just a step towards that. You have to have people involved in your projects that have the experience and are not on a learning curve to make sure that you're going to be successful. So regarding FPTs, I think we're all probably familiar with spray rack testing. One of the things that we do frequently on curtain walls is the AMA 501.1 wind generator with an 84-inch propeller. We have those all over the country. And one of the challenges in curtain wall testing is that to do AMA 502, 503, to do the ASTM E783, you've got to have a termination point in that curtain wall, which curtain walls don't have within their field. So you have to go in and modify that construction to be able to do that test. So in lieu of that, the AMA 501.1 is a great way to approach that without having to do any significant rework or prep and get, I think, a better answer for your project. So air penetration, whole building air tightness testing, 779, E3158, Corps of Engineer. Of course, E1186, whether it's bubble gun at a fastener or thermal infrared scanning or doing smoke tracer. So whole building air tightness testing, and I've talked to a number of y'all about this during the course of the conference so far. This is becoming increasingly required in the codes. In Iecc 2021, it's required. In ASHRAE 90.1 2019, it's required. So if you're not doing it in your specs today, you're going to be doing it in your specs in the next 3 to 6 years. This is coming. And commercial contractors, they get a little freaked out about this because this is something that they don't typically do. They haven't done before. And even on large commercial contractors that have a federal division that have been doing this with folks like me since 2007, the federal side and the commercial side, they don't usually talk to each other. They have very different accounting requirements, very different ways of staffing projects. So as these requirements come forward, you need to make sure that you have the experience and expertise on your team so that not only are the building details going to be such that your client and the contractor can be successful on delivery, but also walking through those critical interface details during the course of the project, and make sure whenever you show up at the end that you can do a test that's actually useful. So this is a case study from a project in Oklahoma where another consultant went out to do whole building air tightness testing on this very simple looking dormitory. It's 4 bedroom modules. They have demising walls between each. It was designed as a single zone for the air barrier at the roof. So the way it was designed and constructed was to test all of these modules together. So it's just a 2-fan test, which is not a big test. But this other contractor ended up, another testing agency, putting 10 different fans in the doors to a bunch of these different modules and just couldn't get to pressure. So they finally said, thank you for your service, and gave us a call and went out there. And the first day, found something that didn't surprise me, and it should have been easy to pick up. So this building is all served by a DOAS. So through the intake and exhaust, they were trying to pressurize with a neutral static pressure at the energy recovery wheel. So guess what was not turning? Guess what was not moving air through the rest of that building? So, John mentioned I've been doing total building commissioning for close to 30 years at this point. Building enclosure, which is more in line with my training and background, since 2007. And, DOAS, energy recovery wheel. So can we just set up the fans at the penthouse door and disconnect the ductwork? We'll use the intake and exhaust to pressurize all the rest of the building. And they said, well, no, that's never going to work because the other guy had 10 fans in all these other doors and couldn't get it to test. Well, I said, well, of course not. So finally I don't know why they hadn't talked to the mechanical engineer up to that point, got him on phone. He said, well, there's no way those fans are going to have enough static pressure to turn that wheel. Yes. So it was a simple fix, but they needed somebody who had experience and expertise and not just a certification and a lot of fans to show up and be able to deliver the value that they needed in the project. So obviously the schedule was blown, contractors spent a lot more money getting people in and out, but now it's a very simple approach to getting this tested. So as we add chilled beams, DOAS to these buildings, it's going to change what the approach has to be, and you need to make sure that you've got a qualified testing agency who knows what they're doing whenever you get there. So this is modified testing agency qualification sheet that the U.S. Army Corps of Engineers has used. I think it goes back to my comment about certification doesn't equal qualification. So ask them to demonstrate that they are not on a learning curve on your project. Ask for half a dozen similar projects. Ask for reference letters and call a couple of them. So people are doing that to you anyway. I mean, how often do we respond that way to an RFP and then we hear from a client who says, so you forgot to tell me you had me in as a reference for this project. But do that and make sure you're able to take advantage of that. So the last thing I want to talk about is around codes. I mentioned it. So What's coming is Iecc 2021, which some states are already in line doing mandatory adoption. So in ASHRAE 90.1 2019, those adoptions are coming. If you don't see them in this next code cycle, you'll see them in the one after that. State codes, we've been doing a lot of testing in Austin. If they have state funding, they have to do a whole building air tightness test. Just came back for testing in Boston. If there's state money on a project in Massachusetts, they have to do whole building air tightness testing. And there's going to be more of that. So some of us have done a lot of buildings at this point because we've been involved in DOD and GSA since the pilot program in '07 and when it became a requirement in 2009. So know that this is coming. Be prepared. And also, I'd make the point, these specs and the building codes require either ASTM E779 or E3158. So I tell you what the delta is. E779, we developed that at ASTM years and years ago with the particular view towards residential. And E779 works fine for residential. It was never intended for large buildings. So E3158, which is in the codes now, we got it in the codes one code cycle previous, and it is based on the work that we did at the Air Barrier Association to develop the original code that became ultimately the Corps of Engineer air leakage test protocol. We took all of the data that the Construction Engineering Research Lab, which is the R&D arm of the U.S. Army Corps of Engineers, we took all of the data that they had from thousands of projects, looked at that, and put that into E3158, which is the ASTM large building. So if you have a whole building air tightness testing spec that you're having to put in, whether it's in a sustainability section in Division 1 or your BECx in Division 1 or in a spec in Division 7, it's important that E3158 is what you're specifying. Also, last thing I want to say about that is there's a grace range in these codes, which the requirement is maximum allowable air leakage of 0.4 CFM per square foot at 75 Pascal, 24 mile an hour wind. So, but they say that if it's just over a 0.4 but under a 0.6, there's a grace range where if you can demonstrate where the air leakage pathways were and you repair those, then you don't have to retest the building. You just have to have evidence of where those leakage pathways were and that you fixed them. However, the building code doesn't require that you do thermal infrared scanning or smoke tracing or anything else. So the other thing I would leave you with is when you're specifying E3158, also make sure that you're requiring E1186, which is tracing air leakage pathways. That way, if your client is just over and you want to save them expense of a whole building air tightness test, if you have that diagnostic testing already in your contract, then you have the tool for the GC to be able to go back, do repairs, and be successful. So, because that's what we want, right? Is successful projects for the GC to be able to build and for the client to be able to take possession and own. So that's my part. Thank you. John?
Yeah.
You're up.
Thank you, Steve. Appreciate it. And as you could probably guess, we could do a whole hour just on whole building air testing. It dominated a lot of what Steve said, and rightfully so, because this has been a big change recently in building enclosure commissioning. And what we're trying to do today is highlight the changes in commissioning outside of MEP. Do I have two mics going? Sorry. Okay. So basically, what we want to do is highlight some of the changes. I think there's a lot of things that I get wrong when predicting the future. This was one of them. We had, like 7 years ago, I think I had 15 fans. And I was just like, we will never need any more fans. Who could ever need more than 15 fans? Well, we've got like 80 fans now. And I just didn't see this thing blowing up. But now that it's codified and everything, it's really taken off. Now, but it's interesting though, right? Because code is what? Code is the minimum that things don't fall down, right? Now, we still have buildings failing this test. However, as commissioning, remember, code minimums, that's not the expectation on us. We're supposed to be efficient and so forth. So when you are outlining a project from the beginning, you can usually go 4 times tighter than code. Still going to do this test, but when you're setting that criteria up in the OPR, we have an obligation as commissioning folks to be efficient. And part of that efficiency is pushing that boundary, but not pushing it beyond what we can do, otherwise the building won't work. So it's always that sweet spot. But thank you, Steve, for that. I appreciate it. So a couple other things too. When you look at it, and I think I almost want to move building enclosure into a primary system. It seems like it's 60% of the time included in a commissioning scope of work, where in the past it was probably 20 and even below that at some point. But the whole thing is, I really don't like talking about systems to be commissioned. I like talking about the OPR and having the performance in the OPR dictate what the commissioning is. So we're going to talk a little bit about air quality. We all learned probably too much about air quality in those last 2 years. But when you think about air quality, it's not a system, right? Yes, MEP is a big part of it, but the enclosure plays a part. The plumbing, I think there's definitely a part there. But even other things like how long a building has sat somewhere, right? And verifying things. And we have people, if air quality is part of a commissioning program, what experts do we need to do that, right? If we just have enclosure and MEP people, are we covered? Do we need industrial hygienists in the conversation, right? Things that we haven't traditionally been there. I say now that half the commissioning team doesn't know that they're on the commissioning team anymore, right? They might not even know what commissioning is. So hopefully we're going to try to, today's going to be a little bit like drinking out of a fire hose, but it's on purpose because we want to expand kind of the conversation on commissioning when we look at things. So, health, safety, wellness in the science of infection is what we're going to talk about a little bit right now. So, when you look at well and fit well and so forth, even before COVID, that was starting to expand the conversation beyond just lead, asbestos, other airborne particulates that we had to be concerned about, because it talked about health. Right? It talked about the value of people enjoying the space, even from lighting and acoustics and some of those other things as well. So we had a little bit of an insight there, and looking at air quality and water quality and thermal comfort. Thermal comfort always cracks me up, because I guarantee you there is no single temperature where everybody in this room would be happy and comfortable, right? So, but I think 10 years ago, maybe even 20 years ago, there might have been, and God forbid what it's going to be 10 years from now, right? So everybody wants to have their their controlled environment and everything. We learned way too much about droplets and all this stuff in the last 2 years, right? But it's important too. Whether COVID is gone or not, it doesn't matter. We know too much now about this that we can't not care about some version of this going forward. And so we have to understand the science of infection and where we are. And obviously SARS and other things occurred before COVID, and there will be a continued learning. But what specifically are we going to do as a reaction to our facilities with what we know now? That's really the fundamental question. It's not going to be how the last 2 years was, but it's not going to be nothing. So what's it going to be, right? Okay, so when you look at it, I've just kind of got a kick out of this. We were going back and looking at some of the old things when COVID first came out. I remember I was one of those guys washing down my groceries, right? I thought that was cool. I yelled at my daughter because she touched the mailbox because the mailman touched it, right? Like, this is, at the time we're like, this is what it is. And then we figure out that it's airborne and all this other stuff. So anyways, we've done a lot of learning. We also saw some interesting things too, where we had buildings that were sitting vacant for a while, right? Who would have thought we didn't have to go to the office, right? And then we go back and then people are worried about, well, should I drink out of the drinking fountain? No one's done this for 3 months, What kind of concerns do we have? We have this leak, this slow leak in the roof that nobody noticed because nobody was around. Yeah, I see there's some stuff growing here, but is that the whole issue, or are there other issues? And so these are things that I think everybody was just more sensitive to, or you come back in and say, I don't remember ever having a headache before, but I have a headache now, right? And I get a crack at it. How many people are working from home right now? Yeah, how many people were working from home 3 years ago? Okay, about a third of the people that were doing it. I think we're all in for a rude awakening, and we're facing the same thing. We're saying, okay, come on back to the office now. And everyone's coming up with every excuse under their sun not to go back to the office, right? But I'm just waiting for it to happen because I know it's gonna happen. It's like, oh, you had me come back, but that printer's giving me a headache, right? We're gonna get all the different excuses as to why we can't come back now, I think. But we are coming back, and we need to do it safely, but we also need to understand, what measures should be taken, what measures might be, contemplated. So obviously we can flush out water systems and so forth. You can test for Legionella and some of those things for this facilities that have really been sitting around for a while. And then the traditional moisture remediation. But, we should anticipate that there could be things that need to be looked at. I think when you look at infection control strategies and so forth, the social isolation, I think we're probably past that part of things. It's nice to be able to see faces and everything again. But what I want to focus on is some of the engineering controls today. And as I said before, we are not MEP people. We're traditionally building enclosure folks with the fire and acoustical habit every once in a while. But we can't just be comfortable in our box and serve our clients' needs. And this is why we need to reach out. And this is why events like this are so great, where you can make those partnerships and those relationships so that you can have an effective commissioning team. But when it comes to actually, realistic infection control strategies, you've got to bridge the gap between multi-disciplines to get there, right? And that's what we're going to look at today. So one of the things, I'm going to pick on a few people just because I fortunately have a few friends. I had friends before I picked on them. We'll see if they're friends afterwards. Dave. Okay. So we have three things that we've all learned that we can do to clean air, right? We can add a bunch of filtration. We can take a bunch of outside air, and we can clean air, right? We learned about those things. If I tell you that we're going to do a ton of outside air, from an energy standpoint, how are you feeling?
Yeah, my energy bill's going to go up a lot higher.
Yeah, not so good, right? Okay, Russell, we're going to do a lot more filtration. We're going to filter. We're going to put like a HEPA 16,000 on this thing, and how are you feeling about the energy side with that? How much? What's going to happen if we start putting 5 filters on this thing?
Well, it'll increase, and where we live, we get no roof, so there's a lot of dust, so there's
Costs with filters. Okay. So you can see we mean well, and we're trying to solve a problem, but we're creating another problem. I had a good friend of mine that says, sure, John, I'll give you healthy air. We can piss away 20 years of energy efficiency. And I'm just like, well, that could be a challenge, right? So what we have to do, and I'm going to thank, so Russell works with EEI, and we've worked closely with EEI on a couple projects now, where we're trying to find the balance, right? There's no textbook for this stuff. We had to figure this out as we went. Because we're trying to find, we can't just look at filtering or outside air or cleaning. It's got to be a combination of those things, but we still have to think about those other tenets that are really important, right? The energy efficiency. It's not like we can give those up where we can have poorly functional buildings. And so we started looking at things like air cleans per hour, which is not a term, we just kind of made it up because it didn't exist. And we're trying to look at it, well, how do we measure this, right? What's a good time? And so we were trying to get it down, to that 30-minute range of an air clean per hour. So that means all the air in the space has been cleaned, right? And then so we started to do that, and things were good. And then we realized we were working on some schools and so forth. What we realized is there's other problems. It's not just about clean air, and we'll get to that in a minute here. But when you balance those three things out, and you keep in mind energy in the background, you can get to that sweet spot. But it takes extra communication. It will probably take reaching out to folks like industrial hygienistry, environmental people, and those are the folks that are really important to bring the whole team together and to be able to solve the problem, right? So when we look about reoccupying the space, right, we have to have good communication and look at all these different roles that are coming in. So, there's as we said before, hygienistry, there's contractors, we might be changing some equipment out. People want to have flexibility and adaptability, right? There are times where they want to be able to say, we're going to go with a ton of outside air. We're going to make sure that this space can really have healthy air. But then when it's over, whatever it is, we want to go back to the way that it was, right? It reminds me of my historic preservation days where you don't do anything that you can't undo to the side of a building, right? But so those are all important things to look at. And then when we look at actually what we're going to be doing and so forth, I think we're going to see some interior design changes. We're already seeing things are spaced out a little bit more. The open concept's hanging in there, which is good. I was wondering if we're all going back to like closed offices again and so forth. It doesn't seem like that's happening. I suspect it will have an influence on our HVAC design. I'd be interested to have some conversations afterwards to see what you're seeing. Certainly new technologies, sensors, cleaning, automatic cleaning, all of those things are already happening because people want to have control over the space that they're in. But I think what's really going to drive IAQ going forward is actually not the health side of things. I think when we look at VOCs and particulates and ozone, CO2 buildup, I think those are the big things that are coming. And we're seeing that a lot of cases where we're working with school districts and schools are already disappointed that kids lost like a year of school, and now they're finding out that they don't have enough oxygen in all of their parts of their classrooms, and it's inhibiting learning and things like that. And there's really a lot of attention that's now being paid to healthy air, not from an infection standpoint, but so it can promote learning and so forth. And again, I do think we are going to get the people that are going to come back that are going to blame the printer for headaches or whatever they can to try to work from home again. So invariably, we'll have to deal with all of that. So kind of going to the next system, we're just going to talk about acoustics real quick too, because acoustics is another one of those things. Acoustics isn't a system. If someone says acoustics are important, what system is that within the OPR? It's mechanical, plumbing, technology, enclosure, it could be all of those things, right? And so if acoustics are an important part of the OPR, we need to make sure we're bringing in all of the team members to look at these things. One of the things that we've seen quite a bit here is changes in how we're handling flooring systems. I probably should have put a tapping machine in here, because one of the things that you don't realize is apparently carpet's not cool except for convention centers, right? So in high rises and so forth, hardwood floors and tiles and so forth, but you never want to hear the person above you. So we have to, as an industry, we have a way to test for that. So somebody to simulate high heels walking on a floor above, and then whatever acoustical mat we have and so forth. All of these things are really changing the way that we are looking at things acoustically far differently than we did before. So one of the tools that we have now too is actually we're doing a lot more modeling on the acoustical side. We have an acoustical camera, which is kind of like an IR camera. So what you see in the picture, it kind of looks like an IR image, but it's not. It's actually for sound pressures and things like that. And so I just want to, again, it's a little bit of just kind of putting a few teasers out there with where these industries are going, but these will impact your commissioning jobs. There will be customers that have this as a desire in their OPR. They want to have certain sound pressures, OITC, STC measurements, and having the tools to put an effective commissioning plan together is important to do that. Okay, sustainability. So when we talk about sustainability touches just about everything, right? And in terms of the systems, if sustainability is important for somebody in the OPR, we need to look at those things. When we look at it, I think, in the building codes and so forth, and Steve did a good job of outlining some of the changes, especially around whole building air testing. We have safety at the top, and the building codes have done that forever. And then we kind of get into the healthy and efficient. But then now we're talking about things like resiliency and green. And I think it can be really confusing. So, one of the biggest things is now everything's green, so really nothing's green, right? Like, how can we sort this out? How do we know if somebody tells us, hey, we want this to be a very sustainable building, a resilient building? How do we accommodate that in our commissioning plan? How do we look at that? So we start looking at things. So resiliency, redundancy, right? So robustness, I think those things make sense. Recovery, so we talked a little bit about that before. That kind of has an adaptability play, right? Where it could be one thing one day, another thing the next day. We can gear up for an event, maybe it's stormproofing, and then we can gear down for an aesthetic that we're looking for. And so all of those things come into play when we're talking about resiliency. One of the other interesting things is, I think, for me, it was kind of eye-opening. I thought I saw Jerry Kettler running around. Is Jerry here? No, he didn't make it. Okay, sorry. I got to give Jerry credit for this. So we were having a conversation the other day about LEED and green and why people are looking at certifications. So when you look at it, so outside of platinum, 2% or less additional construction cost to earn a certification, and we can all have our own opinions about what we think the merits of certification are, but I would just think about the economics for a second. 2% more construction cost, and then when you look at this, when you're looking at increases in rent or premium, it's between 6 and 8% additional money coming in. What owner's not going to do that? Whether they think it works or not, who's not going to do that, right? And I think, those of us in the commissioning, whether we think there's a lot of merit behind certification or not, we have to thank USGBC and LEED because we've got a lot of commissioning out of it, right? And so when you look at just the economics of that, it gets really interesting. The other thing too is when you start to overlay ESG and some things that I probably don't have time to get into today, then people are going to make buying decisions, financing decisions based on sustainability goals and targets. So I think that's going to get really, really interesting. So again, financing, resiliency is going to continue to gain traction. It's not going to go away. I do think that sustainability took a little bit of a pause during our COVID year and a half, but it seems like there's a fire lit under it again. I know if you speak with the CEO of Intertek, he will say that sustainability is the movement of our generation, and he proves to be rarely wrong. So I think there's some plays there. Also, I want to talk a little bit, as Steve introduced, that we were going to talk about just the way we build. And I think that when we think about, modular construction might be the wrong word, off-site fabrication. The way everybody knows the way that we've been building has been antiquated in terms of, when you look at time savings and just the lack of automation, the waste, and all those things. And I think that even from a sustainability standpoint, when you look at how much you can save by having a more efficient process, maybe moving materials around less, the disruption to the site, in terms of the environment, even noise and other things like that. The modular way of building has a lot of real good tenets there that I believe we're going to start seeing kind of the birth of modular. And then also from a quality standpoint, things are done in a more controlled environment. You probably have a little more consistency in trades. I know on the enclosure side, one of the biggest problems we have is the people don't stay in the trades anymore, right? So somebody is an electrician one day, they're a realtor the next day, right? And then maybe they come back and they're a plumber, and you're not getting what we used to get with these master trades people back in the day, 40, 50 years. They would sit there, they would be an apprentice, they would watch, they would learn, and they would do it. Now we make mistakes in our jobs. We learn from those mistakes on the jobs, and the next people come in and do the same thing again. And so that a lot of that can be changed when you get into to more of the factory setting. You get a little more consistency in the labor, a little more routine, and in some cases it's automation with computers and machines and so forth. So, and we did see a lot of actual off-site fabrication overseas. I think the interesting thing is one guy takes a wrong turn in the Suez Canal, and we all of a sudden realize how weak the supply chain is, right? So, anyone want to guess where we're seeing a lot of fabrication coming from right now? It's not China anymore. It's not Vietnam. Not India. Mexico. We got 4 guys. I have 4 guys in Mexico today looking at fabrication because people don't trust shipping containers anymore, but they still trust a truck, right? So I think you're going to see a lot of Latin America, and there's Jim. Look, I won't pick on you. So, but yeah, what we're going to see is the desire for cost savings and fabrication is still there, And for right now, there's a little bit of a disruption in this global economy. I think it'll be about a 5-year pause, and then we'll be right back in with buying materials from all over. Europe desperately still wants to sell materials for us. I mean, I can't tell you the number of curtain walls and thin, lightweight claddings that we saw from Europe over the years. That desire hasn't gone away. But I think there's a little bit of trepidation that people need to get jobs done, and they're afraid that things aren't going to show up on time. So just a couple more slides. So when you look at it for modular, not only does the commissioning exercise need to go there, but also even the code sign-offs and so forth, third-party approvals, all that has to be done in the fabrication plant. You can't do it. You can't wait to show up on site till you see those things. We're going to be seeing high-rises that are modular construction, a whole bunch of interesting things coming up. So this was the project pre-pandemic that we saw, where glass was coming out of China. And you have to do the same test. So you can't wait for something to be unpacked out of a shipping container to go make sure that it's correct. You've got to send the lab, send the expertise, send the commissioning process to the fabrication plant. And then in this particular one, it was fabricated in Croatia and then tested in Germany. But again, you can't miss that key fabrication step. Hope things that go right, hope you pass the test. You have to be there every step of the way. And so we spoke with a bunch of folks before that are doing, I think, embassy work and other things internationally. There are still B projects that are international, and we have to make sure that we remember these key things. So we have to we're the ones that have to accommodate, right? The world is not going to change. We're the ones that need to adapt to what the world was. And this was a project in New Jersey. And then once it gets to site, we can do the normal stuff. But we can't just start with the normal stuff. We can't just say we're going to do design review and some field and mock-up testing on site and call it a day. It's not good enough. We're not controlling the risk for our clients enough. So just have one more slide and we'll get into some questions and everything. And this is kind of where we're going to look into the future a little bit and try to predict some things. I wish I had time to talk about cybersecurity today. There's a whole lot of other things that are beyond MEP that I would have loved to talk about. We had a 50-minute time slot. That time slot's used up, unfortunately. But there's some really exciting things that are coming out with technology. And I also think there's some other changes too, like with even exposure as CX agencies to construction defect claims and so forth. And so there will be some webinars that are coming out. I know ACG's got some, I know BCA has some. So if you want information on some of those things, those topics and everything, I apologize we couldn't get them today, but there will be more information coming out on those things. And all of those will influence our commissioning going forward. But, so what do we think? I think there will be a hesitation in overseas fabrication, 3 to 5 years. It'll still be a global economy. We'll still have some jobs that'll take the risk, but there will be a little bit of pause. We're going to see a ton of stuff from Latin America, even from South America, where we're having our projects fabricated from there. We're going to, there's commissioning is going to be gaining steam, especially in the existing building space. So we've seen that building for a long time. That's not necessarily a new thing, but it won't be dominated by new construction how it has been in the past. And we're going to see a lot of retrofits of existing buildings. So with that, I will stop because I think I'm at my 50 minutes here. Oh, 2 minutes to go. Yeah, no, I didn't see the 10-minute card yet. We have 12 minutes for questions. So actually, if there are topics that you want to talk about that I said we didn't have time to, we have a little bit of time we could talk. We can kind of ad-lib some stuff. But I appreciate everybody's participation and attention. No sleepers today. That was nice. Any questions?
If you have a question, please raise your hand and I'll bring the microphone to you.
I just want to go back to your lead cost premium slide.
Yes.
It's really valuable information, but what I noticed is that it did say it was from 2007, which is before version 3, let alone version 4 and 4.1, and there was a significant increase in scope in V3 and an even more significant one in V4. While at the same time the codes have increased, is there any more recent data that even for version 3 that we could kind of use in conversations?
It was good for you to pick that up. So the 6 and 8% is recent data, right? That's last 18 months. The cost was old data, and I just threw it in there because it was the only data that I had from an old presentation. I didn't have time to look up the new data. I know it doesn't cost 6% more, people wouldn't be doing it, but it might not be 2.2 exactly for gold. So I apologize, I don't have the exact updated data there. And it might have increased a little bit, but even if it's 3-4%, that's still, the math is still working out that it pays to do certification on the back end. Yeah. Yes.
All right, how's this work? Okay, there we go. So at least personally, I look at commissioning as on day X, time Y, this system and this component works. I can't guarantee after it that somebody's coming behind me and jacked something up.
Yeah.
So if we're doing testing on these modular components at the factory, and obviously if they're being shipped from overseas, stuff can fall overboard, you know, people can go in and mess stuff up. How are we able to say to the building owner, hey, I guarantee this stuff works if we're doing the functional testing at the factory?
Well, it's great, because it's not really an either or. It's usually, there is a both component to it. And you're right, things do get messed up in shipping. And I'm going to speak from an enclosure standpoint because that's what we know, right? So you look at glass properties, you look at the coatings of the glass, you look at the way that things were fabricated, you look at properties like solar heat gain, UV, like all of those things, those won't change. But the effectiveness of the seal can change, right? So you could have a seal failure in transit, and also you could have, when the frame is fabricated, like in Croatia, what we saw, you could have shifting, right? So it could pass that mock-up in Germany and fail in the field. So the two key things are, don't do new testing on site that you haven't done in the mock-up, right? So if you do a mock-up or you do a test in the plant, you don't want to introduce new testing when you get to the site. You could do the same testing again to verify that things haven't changed, but it does give you peace of mind that at one point it did pass. And if it doesn't pass then, you don't have to go back to, was it the materials, was it the fabrication? Because you know those were good. It was really the erection or the shipping that was the problem, and it helps hone in those problems for you. So you should do the testing, some version of that, on the project as well to give you that level of assurance. Yeah. It's a good question. Other questions?
Thanks, John. We're seeing more complex curtain walls going in and one-offs that designers want to make a creation, and you've been involved in a few of those lately. What is your thought on the amount of specs we're seeing that are talking about factory assembly testing that are being negated by saying the components are tested, but not the full assembly?
Yes, it's the age-old argument. We've already tested this, and you know, each job is fairly unique. Each job is unique enough. Well, I'm going to take a step back. Yes, lots of custom curtain wall assemblies and so forth. But where do buildings leak? When you talk about the enclosure, they don't usually leak directly through the field of the curtain wall or the wall or the roof. They leak at terminations, penetrations, transitions, right? And so the real value of the mock-up is to test those interfaces. So you don't want to just test a window or test a roof. You want to test them in conjunction with each other. And a lot of times things that are seemingly similar, there's little nuances that make things very difficult. And Steve had mentioned NFPA 285, and this is a good example to bring that up now too. A small change in that header detail can get you drastic changes in the fire resistivity of that outside wall assembly, right? And so even though some of the components have been tested, they haven't been tested by this design and this fabrication with this exact crew at this time. And so I would always encourage you to do a mock-up. I would encourage you to do a mock-up ahead of doing field testing if you have a very slim budget, because you need to do your learning early. But to rely on a spec, test report that was done 5 years ago, that's not going to cut it, especially with high-end curtain wall assemblies. Does that answer your question, Russell? Okay. Thanks. Other questions?
Here.
Can you briefly talk about cybersecurity, please?
Okay. This is an enclosure guy talking about cybersecurity.
So he really wanted you to ask that question.
So as an enclosure guy talking about cybersecurity, I'll do my best. The big fear right now, everybody wants to have information at their fingertips, right? So they want to have information up in the cloud that can go down to their smartphone, that they can control things. The problem is, anytime you involve the cloud, nobody has solved the mystery on how to make that cyber secure, right? When we have closed networks, there are plenty of systems that are out there. The other thing too is we have folks that are trying to tie systems together and get them to talk in a protective manner, but nobody's put that together. And there's a few, BACnet, and there's others that are working on that. But at the end of the day, that's the real big struggle, is the convenience and the social pressure to have everything instantaneous and in the cloud versus having things secure. And it's going to be an arm wrestle. So that's about as deep as I can go for you in a minute.
Quantum computing, anything on that?
Thanks, Jim. Thanks, Jim. I'm glad you came in like with a minute to go here. Yeah, thank you. Any other questions not on quantum computing?
As an industry, I feel like we're still trying to mix the commissioning provider role with the building enclosure expert role and build this building enclosure commissioning process. Steve mentioned the checklist. I wanted to ask a question on that. LEED, the ACG guideline, 202, 2813, and pretty much every RFP you're going to find that's asking for building enclosure commissioning mentions some sort of checklist. Mind you call it a pre-functional checklist, construction checklist, whatever you want to call it. I've had the useless 4-inch binders before for a building that performed very poorly, so it didn't really help anything. What are your suggestions to meet that checklist requirement in all of these different guidelines and actually improve the project and the outcome?
Yeah, and I think that's part of the work that we do in the front end, and not as a PFC, but what is going to be our unique checklist for the systems, the fenestrations, the transitions, terminations that are going to be the below grade that's specific to that project. Have that as an inspection checklist, and as part of the kickoff meeting, review that with the contractor, and because we're quality assurance, right? That's what commissioning is. It's a QA function. But if they need to know what we're looking for, and they need to, hopefully they've got a QC manager that's part of the project, and will push down to the trades as part of their daily activities, doing those same checklists that we're going to come back and do for the project. But it's got to be tailored to the project. Frequently, just customized doesn't cut it. You have to have somebody, I mean, you saw that thermal break detail. If you went back to the manufacturer, it's not going to have all that detail in there. That's what you have to make sure that detail is going to work, and that's just one detail. So, yeah, having the checklist. So I'm glad you clarified that. Brad and I actually were on that project where they wanted PFCs for the building enclosures, and it turned out to be a complete waste of time. And they were doing it to try to cut down on field inspections. And then once we started testing too late in the project, they had failure after failure after failure. So it just reinforced for me, and this has been a few years back, reinforced for me how important that unique process and different process is for enclosure commissioning compared to what we would do on HVACR commissioning.
Thank you so much. Great presentation.
Thank you.